Hello everyone, welcome back to the channel. My name is Kevin Tamakwala and today we are going to discuss another LeetCode problem of the day, which is extra characters in a string, right? So in this question we are given a string S and we had also given us words a dictionary, right? We are also given a dictionary of words, right? Now we have to break string S into one or more non-overlapping substrings such that each substring is present in the dictionary, right? Okay. There may be some extra characters in S which are not present in any of the substrings, right? So we have to return the minimum number of extra characters left if we break the string optimally, right? So in this case, in this example, we are given a leets code, right? Leets code is our example, and this is our dictionary, right? So how we can break? So if we break leet, right? If we break leet, and if we break code, so we can get only one extra character, which is s, right? So we have to break string optimally such that we can have only minimum number of extra characters left, right? So in this case, another example, say hello world, right? So say hello world is our example. Now if we break our string as hello, and if we break our string as word, so we are getting three extra characters, right? Okay, so let us assume, let us take this example, leads code, right? And this is my dictionary, which is LE. Let us say I'm having LET leet, right? I'm also having code, and I am also having leet code, right? So this is our, let us assume this is our dictionary, just a single modification that I'm having LE, right? Now we have to break our substring such that this string s such that we are getting minimum number of characters left, right? So how we can approach this? So if I take this example, I can break this like this. I can take LE, right? I can also take CODE code, right? So I'm in this case I'm getting three extra characters, right? In this case I'm getting three extra characters. But what if I am also having another value as leets, right? Let us say if I am having this, so I can break this string entirely. So I am having, in this case I am having zero characters, right? So now I want to try for each and every possible characters that I have to check that is LE present, right? I have to check is L present, is LE present, is LEE present, right? Is LEET present, right? So in this case, we can solve our problem, and we can check, and we can apply the minimum number of characters which are not present, right, which are not present, right? So that would be brute force that generating all the order of n square substrings, and that would definitely give us a time limit exceed. Or so in this case we are having a lesser constraint, so it won't give the TRE, right? But that's not the most optimal solution, right? So how you can think of, right? How you can think of? So let us take this example. Let us take this example. I'm starting with string s. I'm starting with string s, and my initial pointer is I. Right. So this is nothing but I'm thinking of an approach, right? So initially I'm having L. Right? So what are the possible? And I'm calling a function f and with index 0 and my string s, right? So now I am passing. I'm calling this function, right, from my main function. Now I am calling this. I am having this L, right? So now what I'm doing with L, like I'm trying all the possible ways. I'm trying all the possible ways, right? Starting from LE, I am moving to COD, right? I'm checking for all the possible cases. Right? I have to generate all the substrings. Please generate all the possible substrings for me, right? So I am calling f of uh, 1 comma s, right? If I take, or you can say if I take this, right? If I take this e, so what is our string? What is our string, right? So I am having le, I am having le, right? And I have taken this string 1 plus, right? So this gives me that what are the number of characters I am having, what are the number of characters I am having, right? Now let us assume I am having currently my string le, I am currently having my string le, right. I have to check whether it exists in my dictionary, whether it exists in my dictionary. If it exists, start my recursion call for e, right. So assume if it exists in dictionary, right? So I am starting my dictionary call, or making another call from index number 2, from index number 2, and I am having my string as s, right? Because this is now my string, or you can say I am having this true, and I have explored this string, right? So now I am checking that how many minimum characters are there for this string, right? I can also get another possible string. I can also get another possible string. So that's why I'm getting minimum. That's why I'm getting minimum, right. This is how I'm building my intuition, right? That if I pass, or you can say if I start this from here, and I want to minimize my answer, right? So initially let us have initialize my answer to max, int max, right? I have my int max is my answer. Now if I find le in my string, le in my dictionary, I am starting my another recursion call from here, that I have got this, in my dictionary, so this cannot be my answer, what is my answer? That I want to find the leftover part, right? So these two characters cannot be my answer, so please start my recursion call for here, right? Recursion call for here. Right. So this is how it works. And why one comma s? Because let us say I'm not picking this. I'm not picking this L. I'm not picking this L. I am not picking this L. I am simply adding one, that I have found one extra leftover character. I found extra leftover character, right? And I will be taking minimum of these two things, right? So let us say if I am finding L here, so adding one to it won't make any difference, because I am getting minimum from these two. So this won't be contributing in my answer, because I am adding a one to it, right. And let us say if I don't find it in my answer, so that is a part of my leftover string. So that's why I'm adding L plus one to it, right? Now again, starting from one, I am going to similarly 1 plus f of 2 commas. Similarly, I am fetching le. Right? I am on index number 2. Right now, I am checking for each and every possibilities. Right, right. So uh, from here also, yes, from here also, I am making another multiple calls f of 3 commas. Right, so on, right? So up to I'm generating all the possible substrings, right? Up to I'm generating all the possible substrings if they exist. Let us say in this case I'm finding le, again I'm finding l again I'm finding l right? So I'm generating all the possible substrings up to n minus 1 comma s. Right, so this is how my recursion calls goes, right? I have taken this one case only before, but I will be building that. I want to check for all the possible substrings starting with index number 0, right? Index number 0 up to 1, 0 to 1, right? This is nothing but 0 to 2, this is nothing but 0 to 3, right? Right. So I am now calling for this is f of 2 commas, right? F of 2 commas. So this is nothing but starting from 1 to index number what you can say, it should be 3 here. It should be 3 here, starting from 1 to index number 2, right. Please make my call, right. Similarly, starting from 1 to index number 3, so this would be 4 commas. So this is how I'm making all the, and you can see I'm getting overlapping subproblems. So this is how you can think of dynamic programming solution. So this is not quick, and this all substrings I'm generating, right. So this is quick. So if you don't simply write the recursion, and if you calculate each and every step, so the time complexity would be order of n square, right? This is the time complexity, and similarly the space complexity would be also order of n square, right? I'm making an n square recursion calls at max, because let us say if I'm having in my dictionary all the possible substrings, I'm having order of n square, or you can say n square substrings. So I will be getting at max n square calls, right? So this is how I am generating. So what is this recursion call meaning? It is telling me that I am having starting from 1, which is le index, right? I am having, so this is first index, this is second index. So this ee is in my dictionary, right? If it is in my dictionary, please make my call, right. For because I'm this thing, and I take minimum for all that. Why minimum? Because I want to find the minimum leftover characters, right? And I'm adding one here because I'm assuming that this can be in my leftover character, right? I'm assuming this can be it. If it exists in my leftover character, so it could be automatically contributing in my this answer, right? Definitely, right? So this is how our recursion is built. Now let us just quickly write a code for it, right? We can do live coding, but as you can see, we are also having two, or you can say multiple sub problems repeating, right? So this is how you can think of dynamic programming approach, right? So let us just quickly code it up, right? So let us assume we are having a string let us take set. Why I'm taking set? Because I want to find, or I want to apply the find method on the string, right? So that would take a lesser time than searching in vectors. So that's why I'm building my set, right? Right. So I'm simply inserting my iterator, or you can say I'm simply inserting all the my dictionary words into my set. Right. So now share it over here. Right. Now I'm fetching my size. Now I'm making a recursion call. Right. So I'm simply returning my sol, and that will be 0, s. Right. So this is how I made build my recursion, right? So let us say I'm having this solve function returns me how many leftover characters are there, right? So this is my integer I, or you can say index, and I'm having string first, right? Now if my this is my base case, that if my exceeds the length of the string exceeds, so I'm declaring length here, right? So this is my base case that I'm go out of the bound. I go out of the bound for index, right? So the return 0, that I won't be having any string here. I won't be having any string here, right? Now I have to find the minimize that I'm minimizing. So I will be making int not pick. This is nothing but not pick. That I am making the recursion call for index plus 1, and I'm passing the same string as, right? Now what I'm trying to do is I'm defining my answer. So my answer is maximum limit. This is nothing but int max. Now I am simply generating all the possible substrings. So how I can generate? So I'm starting from index number 1 to I less than n minus index. In this way that I plus index should be lesser than n. So simply doing I plus plus. Now if I what I can say, if my st dot find, I'm finding the string, right? So what will be my string? So I'm generating my string, or you can simply write string str, or to search. To search is my string, and I'm generating a substring, right? So it's starting from index to I up to I. I'm starting from index, right? Starting from ith value, or this is my index value. I'm generating my substring from ith index, right? So this is how I'm generating my substring. So to search, I am passing it should be not equal to st dot 10. Right? So this is how I am searching. Right? So if I found a string, if I found my string in my set, right? So I'm simply minimizing my answer. I'm simply minimizing my answer. Right? So this is how I guess this should work, and I'm simply returning n of answer comma not pick. Let me just quickly run. Okay, so it is giving me wrong answer. Why it is giving me wrong answer? So uh, okay, so I forgot it. I forgot to add a plus one here. I forgot to add a plus one here, and also I forgot to I see if I find my string, if I find my string in my set, so I will be moving my see I got my string as le. Suppose assume le is in my dictionary, right? So now I will be moving my pointer from L to E. I would be jumping by plus I index, or plus that much steps I would be jumping. So let us say I find L double ET lead. So at the first index I am fighting. I am searching, right? For L I am searching. So now I will be moving straight away to C. Right? I won't be doing recursion call for this. Right. Right. Because I picked that. I picked that. So I picked that. I picked this substring. Now I'm simply searching for another substring. Right. So this is how I should have written this. Right, so now let me just quickly submit this. But before submitting, this would definitely give me a time limit exit. So as you can see, I got a time limit exit, right? But if I let us say if I defining a DP, right? So let us just define a DP, right? And this is my define. I defined a DP, right? And now I'm simply checking that if my DP of index is not equal to -1, simply return DP of index. So I just simply memorize this solution. Now, if I quickly run this, I guess this should work. And if I submit this, it gives me accepted solution. So this is how you can memoize your recursion to dynamic programming. And see, I'm generating all my possible substrings for my index. Index, right? I plus one, I'm index each and every time. This, see, index plus I, I'm doing at up to n, up to this thing, generate all the possible substrings. Up to n, generate all possible substrings for me, right? And find the recursion call up to this and check it if it exists in my dictionary. So please move that. Please pick that. Please pick that. Please pick that. So this is nothing but a pick operation, and this is nothing but a not pick operation. You're not picking it. I don't want to pick it. So please ignore that and add a one, because this is my leftover part. This is also my leftover part. Right? And simply I have why I have written set, because this improves my searching. This improves my searching, right, to logarithmic complexity. It should be n log n in case of string, right? So yeah, it improves my searching instead of vector. So for vector, it would be maybe it would be the length of string into the size of the vector. So that would be the complexity for searching in vectors. So this is how you can define a set. So thank you very much, guys.